And what an analog scale is it's the kind of scale that has lines on it. Some of the lines are numbered, some of the lines are not numbered. And the smallest lines on the scale, there's spaces in between them. The places that you're going to run into an analog scale, you're going to find an analog scale on a ruler where there's lines with numbers. And then there's little lines in between, lines with numbers, and then little lines in between those lines with numbers. So you're going to find that on a ruler, but you'll also find that on a triple beam balance, where you have the triple beams, and you move the sliders along the triple beams, and you have to look at where you are in between the lines on the smallest rider. So a triple beam balance is an analog scale. You're also going to find an analog scale on the spring scales that we use, where there's a little hook that you hang something from, and there's lines on it that show you what your measurement is. So a spring scale has an analog scale. And another thing you're going to run into that has an analog scale on it is a graduated cylinder, where again there's lines on it, and you look at which line the liquid that you put into lines up with. So these are things you're going to run into that have an analog scale. And no matter which thing it is, the analog scale is going to work the same way. You're going to measure on that scale in the same way, and that's going to include estimating one more uncertain digit on that scale. So that's what we're going to take a look at here. So this thing right here is a ruler, but it could also represent any analog scale. But we're going to say that this is a ruler, and that on this ruler it's calibrated in centimeters. So that means this number here represents 1 centimeter, this number here represents 2 centimeters, and you can see that this distance from here to here, which is 1 centimeter on the ruler, is divided into 10 little segments. 1, 2, 3, 4, 5, and the line is a little bit longer there, so it's easier to find 5 tenths of the way across. 6, 7, 8, 9, and this brings us to 10. So each of those spaces is a tenth of a centimeter, or 0.1 centimeters. So the scale itself goes down to the tenth of a centimeter. But you can see that there's spaces in between those lines. And what we're going to do is we're going to estimate how far in between two lines the measurement actually comes to. So if we, in our mind's eye, take a look at this space right here between 0.6 centimeters and 0.7 centimeters, we can imagine that this space right in here is divided into another 10 little segments. It's not on the ruler, but we can imagine what that would be like. That would be 5 tenths of a way, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those lines are not actually on this ruler, but we can kind of imagine them. When we're measuring, if the measuring scale allows us to go down to the tenth of a centimeter, we can measure on this scale, we can measure one more decimal place. We can measure down to the nearest hundredth of a centimeter, or 0.01 centimeters. So let's take a look at how that works. If I drop this arrow right about there, one thing that I know absolutely and for certain about the position of that arrow is that it's more than 1.2 centimeters. So I know that it's more than 1.2 centimeters. And I know that it's less than 1.3 centimeters. So when I go to write what this measurement is, I'm going to measure up to the nearest mark. So that means starting here, I'm going to measure up to that nearest mark, which gets me to the 1.2. I'm absolutely certain of the 1, and I'm absolutely certain of the 0.2. I know it's more than 1.2 centimeters. And I know it's less than 1.3 centimeters. So how many hundredths of a centimeter more than 1.2 centimeters is it? If I look at the position of that arrow there, I can say it's a little more than 5/10 of the way between 1.2 and 1.3. I'm going to say it's about 6/10 of the way between 1.2 and 1.3. I'm not really certain of that digit right there. So on the diagram here, I'm going to write it in red, and I'm also going to put a squiggle underneath it. Now, why add that last uncertain digit on there? Well, estimating that one last digit gets us closer to the actual measurement than rounding down to 1.2 would, or rounding up to 1.3. So calling it 1.26 gets us closer to the actual measurement than rounding down or rounding up would. So I'm going to call that 1.26 centimeters. That digit that I have there, the digit that I have written in red, that's an estimated digit. I can also call that an uncertain digit. But that uncertain digit gets us closer to the actual measurement than rounding. So let's take a look at another example. If I move this arrow now to a new location, and I'll drop it in right there, I know absolutely and for certain that the position of that arrow is more than 2.1. It's more than 2.1 centimeters, and I know absolutely and for certain that it's less than 2.2 centimeters. So I'm going to do the same thing that I did before. I'm going to measure up to the nearest mark, which gets us to the 2.1 mark. I'm absolutely certain of those two digits. I have no doubt about those two digits, but now what I need to do is I need to estimate how far in between 2.1 centimeters and 2.2 centimeters I am. I'm definitely more than 5/10 of the way, and I'm going to estimate, and I'm going to write in my one uncertain digit, and I can only do one uncertain digit. I can only bring this down to 100th of a centimeter, and I'm going to call that 2.19 centimeters. And that's my uncertain digit. It gets me closer to the actual position of that arrow than rounding to 2.1 centimeters or rounding to 2.2 centimeters. I want to show a couple of other special case scenarios when you're measuring like this. If I put this arrow right there, it's falling directly on one of the lines. Well, let's take a look at which line it's falling directly on. It's right on the 1.2 centimeters. So I know absolutely and for certain 1.2 centimeters, and I know it's less than 1.3 centimeters. And it's right on the 1.2. Now, if it's exactly 1.2, you might think, wow, I could just record it as 1.2 centimeters. But remember, when using this scale, because the scale has lines for tenths of a centimeter, I can estimate down to hundredths of a centimeter. So I still need to include that one last estimated digit. I still need to include that digit that goes right there. And in this case, because it falls right on that line, I'm going to call that estimated digit, I'm going to estimate that that digit is a 0. So I'm going to record this measurement as 1.20 centimeters. 0 is my estimated digit, 0 is my uncertain digit. I need to include it there because when measuring with this measuring instrument, I need to measure down to the nearest hundredth of a centimeter, to the 0.01 centimeter place. Another special case scenario here. If I move this arrow to a new place and drop it in right there. So what would I record this as? Well, it looks like it falls right on the line for the 2. So I can record that as 2. But I can't just record it to the ones place. I have to record it to the hundredths place, to the 0.01 place. Well, I'm certain of the 2.0. I'm certain that it's 2.0. And then I can estimate one more place, and that's going to be a 0 also. So when I record the measurement for the position of this line right here, I would record it as 2.00 grams. The last digit there is that estimated digit. Well, let me give you a couple of practice problems. I'm going to put the arrow in a few different locations here. And what you need to do is try to record, how would you record that measurement? Okay, we'll call this one right here A. We'll call this one B, and then C, and then D. So take a look at the positions of those and figure out how you would record those measurements right there. Make sure you record them to the nearest 0.01 centimeters, to the nearest hundredth of a centimeter. And make sure you include the unit. Always include the unit when you're writing down measurements. And in this case, the unit is going to be centimeters. So try those 4. If you have any questions about it, please let me know so I can answer questions for you. All right, thanks.